Alright, what I want to do is show you basically how we can use synthetic division to factor a polynomial. If we're going to do this, what we need to do is find some roots. Alright, and what I'm assuming is that you can already do that using your calculator. What I've done is I put this equation into the calculator and I graphed it. Okay, I changed my windows, so you can take a quick look at what I changed my windows to be. Alright, my x values are going from -5 to 7. Okay, so what I know right now by looking at this graph, and you can verify this by finding the zeros with your calculator, that I have a root of -2, 0, and 5. Right, one of the things I need to know about this root right here is that this has even multiplicity. Okay, because the polynomial comes down, hits the root right at 0, turns around, and goes back up. Okay. We also know that we're going to have at least 4 roots. Okay. What I've done here is this has already been factored. Here are your answers. Here are all the roots. Okay. We're basically going to use synthetic division to prove that. So first thing I'm going to do is I'm going to factor out an x. All right. I notice that there's an x in every term of this polynomial, so we'll factor out an x. If we factor out an x, we are left with x to the third minus 8x squared plus 5x plus 50. Okay? Now, we also know now that one of our roots is -2. So what we can do is use synthetic division to break this down a little bit. So what we do is we put a root of -2, and we put it in a little box right here, and we bring down the coefficient of each term we have left in the polynomial. So we'll get 1, -8, 5, and 50. Okay? Now what I'm going to do is I'm going to bring this 1 down. Okay? Next thing we're going to do is multiply that 1 by -2. What do we get? -2. -8 and -2 make -10. So we'll get -10 times -2, and we're going to get 20. 5 plus 20 is 25. 25 times -2 is -50. So we have no remainder. We're in good shape. Let's see what we're left with. Okay. So what we're going to be left with here is this will be x squared minus 10x plus 25. Okay. Now remember, we've already factored out an x up here, and if -2 is a root, then we know the term that goes with that -2 is x plus 2. And the term that goes with x, or the root of 0, is just x. Okay, so our first term can't be factored. X plus 2 can't be factored. But our last term of x squared minus 10x plus 25 definitely can. So what this factors to is x minus 5 times x minus 5. Alright, and here's what we're left with. We know that a root here would be 0. A root here is -2. A root there is 5. And a root there is 5. Okay? When we have this situation where we have a difference, where we have the root of -5 occurring twice, that's why up here it says the root of 5 has a multiplicity of 2. Okay, so obviously our final factored answer already in red here. Okay, how do you tell about multiplicity? Well, you got that exponent right there that helps you. So that's just one example on how to use synthetic division to sort of break down a polynomial. Again, you need to know how to find the roots if you're going to do that. So if we could just go to an additional problem here. Alright, what I've done is I have an additional problem here for you to look at. The answer there is provided. So again, what I would recommend is finding all the roots as best you can, finding as many of them as you can, and sort of breaking it down one by one. Alright, thanks a lot.